Good morning. Next topic what we are going to see is about electrostatic potential energy and electrostatic potential. So we are going to find the equations for this electrostatic potential energy as well as electrostatic potential. For this, consider a point charge Q which is fixed at the origin. Next is, and let us consider P be a point, a positive charge, that is Q dash, which is placed and brought from R to the point P. So first is we are going to consider only the point plus Q. Next is we are going to consider Q dash, which is brought from the point R to the point P. And so the external force is done to move the point, and it is opposite to the Coulomb force. So to move this charge from this point to this point, some external force is done. External force is given, and that external force seems to be opposite to the Coulomb force, and so we are writing as external force. So F ext, that is equal to opposite, and so we are writing minus of F of Coulomb. Next is writing the formula for work done. We know already the work done is equal to force into displacement. Displacement we are considering as dr, and so integral of F dot dr. And as we know that we are moving from the point R to the point P, the integral limits we are writing as R to the point P. Next is the potential energy at the P. At the point P, the potential energy is given by U of P, and at the point R, the potential energy is given by UR. Next is, if we want to know the difference in the potential energy, that is given by UP minus UR, and that is equal to the work done. And so this difference in the potential energy is given as del U, which is equal to W. And so already we have written the formula for W. Instead of W, we are writing as del U. Next is, we are going to take the formula for force. Already we know the formula for force, which is QE. Here we are writing as minus F of Coulomb, and so minus Q dash of E. So this F, you write it in this place. Now bring this Q dash outside. Next is this del Q, we are going to divide by Q dash, and so we get the potential energy per unit charge. And so del Q by U dash, which is equal to this term divided by del Q dash. So Q dash get cancelled, and so we get only this term. In this we are writing minus term outside. Next is the potential energy per unit charge is given by the difference in the potentials, and so Vp minus Vr, that is given as del V. So instead of this del U by Q dash, we are writing as del V. So that is what is given in the next step, that is del V, which is equal to E dash E vector dot dr. Next is the definition for electric potential. What is electric potential means? That is equal to the work done by an external force to bring a unit positive charge from infinity to a point. So from either infinity or wherever it is, we are going to bring a charge to the point P. For that, how much amount of work is done? So எங்கேயோ இருந்து ஒரு பாயிண்ட் வந்து இந்த பாயிண்ட் பி அப்படின்ற இடத்துக்கு கொண்டு வரதுக்கு எவ்வளோ அமௌண்ட் ஆஃப் ஒர்க் டன் இருக்கு அப்படின்னு பார்த்தா that is equal to the electric potential. So the electric potential is equal to the work done by an external force to bring a unit positive charge from infinity to the point P. So this is about the electric potential and electric potential energy. Next is we are going to see the electric potential due to a point charge. So we are going to consider only a single charge, consider a positive charge, and P is a point at distance R from the charge Q. Next is, we know the formula for V. V is given by integral of minus E vector dot dr vector, and already we know the formula for E also, that is given by 1 by 4 pi epsilon naught Q by R square into R cap. This we have seen already in the last class itself. The formula for V, which is given by 1 by 4 pi epsilon naught Q by R square into R cap. This value of E, substitute in this place, and this 1 by 4 pi epsilon naught we are taking outside, and the remaining is q by r square into r cap dot dr vector. Now this r cap dot dr, instead of this dr vector, that can be written as r cap dot dr, and so instead of this I am writing as r cap dot dr. And we know already that when you multiply any two unit vectors, that is equal to 1, and so r cap dot r cap is equal to 1, and the remaining is just 1 by r square into dr. Now when we integrate this, so integral I have done separately, integral of 1 by r square into dr. So 1 by r square, when you are taking to the numerator, that becomes as r power minus 2. Now the formula for integration is x power minus n plus 1 divided by minus n plus 1. So instead of n we have the term 2 here, and so r power minus 2 plus 1 divided by minus 2 plus 1. So minus 2 plus 1 is minus 1. Again here we have minus 1, and so r power minus 1 can be written as 1 by r, and so this becomes as minus 1 by r. And so instead of this integral, we write with this term minus 1 by r. And now apply the limits. How to apply the limits is upper limit minus lower limit. So upper limit is minus 1 by r, minus of again the lower limit, and so we get 1 by infinity. This becomes 0, and so we get only with minus 1 by r. Already we have a minus sign outside, so when we multiply this we get q by 4 pi epsilon naught into 1 by r. So this gives the equation for electric potential due to a point charge. Thank you.